Confidence intervals and percent significance level. Let us understand the topic confidence intervals, percent significance level. Let us consider the two-sided test for population mu of a normal distribution. You reject the null hypothesis, H0, when x bar is less than C1 or x bar is greater than C2, where the threshold limits are based on alpha, the significance level. In other words, if C1 less than x bar is less than C2, we accept null hypothesis. The values of C1 and C2, threshold limit, depend upon alpha and mu naught. Thus, C1, C2, is the interval within which x bar should lie to accept null hypothesis. Similarly, you may propose an interval around the x bar within which mu will lie when x bar is known. This interval is called the confidence interval. Specifically, x bar minus k and x bar plus k is a 100 multiplied by 1 minus alpha % confidence interval for mu. If probability of x bar minus k is less than mu less than x bar plus k equals 1 minus alpha, then alpha is the probability of lying outside the range. Also, probability of x bar minus k is less than mu less than x bar plus k equals 1 minus alpha is equivalent to probability mu minus k is less than x bar less than mu plus k equals 1 minus alpha, or probability of minus k multiplied by square root n by sigma is less than z less than k multiplied by square root n by sigma equals 1 minus alpha. For a 95% confidence interval, alpha equals 0.05. Hence k multiplied by square root n by sigma equals 1.96, and for a 99% confidence interval, alpha equals 0.01 and k multiplied by square root n by sigma equals 2.57. Thus, a 95% confidence interval for mu is x bar minus 1.96 multiplied by sigma by square root n, x bar plus 1.96 multiplied by sigma by square root n, and a 99% confidence interval is x bar minus 2.57 multiplied by sigma by square root n, x bar plus 2.57 multiplied by sigma by square root n. As we've already discussed, x bar is the sample mean that is an estimate of the mu. Such an estimate, where you get a single numerical value based on the sample data, is called a point estimate of mu.